Hello everyone and welcome to Fleming's Math. This video covers a quiz review on finding limits analytically. Now you'll definitely see a problem like this on the quiz. We have the limit as x approaches 5 of x cubed minus 125 all over x minus 5. The first thing you'll do is direct substitution, plugging in the 5 for x, and that establishes a 0 over 0 case. So that means that we do need to keep going. Now let me remind you of a formula that you'll need. The first one is x cubed or a cubed minus b cubed, and that is equal to a minus b times a squared plus ab plus b squared. And of course, if you have the plus in the middle, then it's very similar. But as you can see, in this problem we have x cubed minus 125. Now, 125 is actually 5 to the third power. So, x cubed minus 5 cubed follows the format of a cubed minus b cubed, where a would be x and b would be 5. So with that in mind, x cubed minus 5 cubed, following this format here, this formula, would become x minus 5, that's the a minus b part, times x squared plus 5 times x plus 25. And that is the a squared plus ab plus b squared part of the formula. As you can see, we have x minus 5 on the top and bottom, so those will end up canceling out. So now we just have the limit as x approaches 5 of x squared plus 5x plus 25. Now we can do direct substitution, plugging in 5 for x. So that's going to end up being 5 squared plus 5 times 5 plus 25. And actually, you really don't even need the limit at this point because you're doing direct substitution. Well, 5 squared plus 5 times 5 plus 25 equals 75 for our final answer. So that is the limit. You'll also see a question like this. Limit as x approaches negative 6 of 2x squared plus 15x plus 18, all divided by x squared plus 4x minus 12. Well, the first question you're probably asking yourself is this going to be the 0 over 0 case? And yes, it is. We won't go through the details, but if you plug in negative 6 on the top and on the bottom, you will get 0 over 0. So then we need to keep going. And the next step would be to figure out how you're going to factor this numerator. How do you factor 2x squared plus 15x plus 18? Well, over here I discussed how to do that. So to factor that, you multiply the 2 times the 18, that gives you 36. And then you find two numbers that multiply to 36, but that would also add up to 15. And that would be 12 and 3. 12 times 3 is 36. And 12 plus 3 is 15. Now we will separate the 15 into 12x plus the 3x. So we're just rewriting everything as 2x squared plus 12x plus 3x plus 18. Now we will group the first two together. That's 2x squared plus 12x in the first group. And in the second group you have 3x plus 18. The greatest common factor in this first group is 2x. So we pull out a 2x, leaving us with x plus 6 in parentheses. The second group has a greatest common factor of 3 that we pull out. That leaves us with x plus 6 in parentheses. We see now that we have a common factor of x plus 6. So x plus 6 is pulled out, and that leaves us with 2x plus 3. And that goes in the second group. So the factorization of 2x squared plus 15x plus 18 is x plus 6 times 2x plus 3. Now we carry that over into the second line. And then we also factor the denominator. What multiplies to negative 12 and adds up to 4 is going to be positive 6 and negative 2. So we have the complete factorization of the top and the bottom. Now you see that we have the x plus 6's canceling each other. That leaves us with 2x plus 3 over x minus 2. And now we can do direct substitution, plugging negative 6 in for the x values. We end up with negative 9 on the top and negative 8 on the bottom, leaving us with a final answer of 9/8. Now we'll take a quick look at the Day 7 classwork. So we've already seen this in class, but we'll do it again here on the video as well. So number 13, you have the limit as x approaches 8 of this expression. We see we have the radical in the numerator, and so we want to rationalize the numerator. So we'll have to multiply the top and bottom by the conjugate of the numerator. The conjugate of the numerator is the radical plus 3. So we do that on the top and bottom. The next step is to distribute. So when you do radical x plus 1 times radical x plus 1, that's just going to be x plus 1, which is that there. And then radical times 3 is going to be 3 radical. And then negative 3 times radical is negative 3 radical. So those will end up canceling out. So then the only thing left on the top is negative 3 times positive 3, which is minus 9. On the bottom, you have the x minus 8 multiplied by the quantity here in parentheses. So we just put that on the bottom. Simplifying that further, the 1 take away 9 is minus 8, or negative 8. So we have x minus 8 on the top, and we also have x minus 8 on the bottom. Those will end up canceling each other, and so what's left now is 1 on the top, and then radical x plus 1 plus 3 on the bottom, and that's the limit as x approaches 8. Now let's do direct substitution, and you're going to end up with 1 over 6. That's plugging in 8 on the bottom. That's 8 plus 1 is 9, square root of 9 is 3, and then 3 plus 3 is 6 on the bottom. So this is our final answer for number 13, 1 over 6. All right, for number 14, so the limit as x approaches 2 of this expression. Again, we have a radical in the numerator, so we're going to rationalize that by multiplying by the conjugate. And the conjugate of 2 minus the radical is 2 plus the radical. So we multiply that on the top and on the bottom. The next thing is to distribute, and of course we'll do the 2 times 2, that's going to make 4, and then 2 times the radical and 2 times the negative radical cancel out. So then what's left is the negative radical times the positive radical, and that's just going to give you the 2x without the radical, and that's going to be a minus in the middle. All right, the next step is to factor wherever possible. In the numerator, we can pull out a 2 as the common factor, leaving us with 2 minus x. In the denominator, this 3x minus 6 has a common factor of 3 that we pull out. So that's 3 times x minus 2. Then the next step, we realize that 2 minus x and x minus 2 cancel each other out, but that's going to leave us with negative 1. So that means on the top we have 2 times negative 1, or which is negative 2, all divided by 3 times the quantity in parentheses. Now we can do direct substitution. If you plug in 2 for x, that would be 2 times 2 is 4, and the square root of 4 is 2, and 2 plus 2 is 4, and 4 times 3 is 12. So that's negative 2 divided by 12, which reduces to negative 1 over 6. That's our final answer. Now I should mention for number 15, or before we do 15, is that you should always do direct substitution first, just in case that it is not the 0 over 0 case. Because if it's not 0 over 0, then you have a lot less work to do. If you plug in 3 directly for the x's, you'll end up with a 1 on the top and a 0 on the bottom. So this is a case where it's not the 0 over 0 case. So let's just go ahead and do direct substitution. If you plug in 3 for x, that's 3 plus 1 is 4, and the square root of 4 is 2 here. Plugging in 3 for this x, 3 minus 2 is 1, and the square root of 1 is 1. There's a minus in the middle, so we have 2 minus 1 on the top. Plugging in 3 in the denominator, 3 squared is 9, minus 9 does give us 0. So on the top, 2 minus 1 is 1, divided by 0. So this is not the 0 over 0 case, and this is actually undefined. Whenever you have a number on top divided by 0, it is undefined, which means the limit does not exist. And here's number 16. Limit as h approaches 0 of this expression. First, we're going to expand the 3 plus h squared. 3 plus h squared is going to be 9 plus 6x plus h squared. Then you add your 3 plus h, which is here. And then 3 squared is 9, plus 3 makes 12, so that's minus 12 on the end, which is here. All that is divided by h. In the next step, we combine like terms. We have 9 plus 3, that's 12. And then minus 12 is 0. So the 9, 3, and negative 12 are eliminated. You also have 6h plus h. Well, that's going to be 7h here. And then we bring down the h squared. In the next step, we can factor out an h from the numerator, leaving us with 7 plus h in parentheses. And now you can see that the h's will cancel out. So now we have the limit as h approaches 0 of 7 plus h. Using direct substitution and replacing the h with 0, you're going to get a final answer of 7. For number 17, it is the limit as h approaches 0 of this expression. We're going to expand x plus h squared. So x plus h squared is x squared plus 2 times xh plus h squared. We add on the x plus h here, and then we subtract the x squared and the x. So that's going to be minus x squared minus x on the end. This x squared and that minus x squared will cancel out. This positive x and this negative x also cancel out. And that leaves us with 2xh plus h squared plus h all over h. We have an h in common, which we factor out, and that leaves us with 2x plus h plus 1 in parentheses. This h over the other h will cancel out. So now we have the limit as h approaches 0 of 2x plus h plus 1, and then we can do direct substitution. Replacing h with 0, we get a final limit of 2x plus 1. All right, and then this is the beginning of the homework on the other page. Day 7 homework, starting with number 18. F of x is the square root of x, and we're finding the limit as x approaches 4 of this expression. Well, what is f of x? F of x is the square root of x. And then what is f of 4? F of 4 would be the square root of 4, which is going to be 2. So f of x becomes square root of x, and f of 4 becomes 2 on the top. Now we'll need to rationalize the numerator, so we'll multiply by the conjugate. And the conjugate of square root of x minus 2 is the square root of x plus 2. And we'll do that on the top and bottom. Now we just distribute everywhere. You're going to multiply the square root of x times the square root of x. That's just going to be x here. And then square root of x times 2 and negative 2 times the square root of x. Those will end up canceling. And then you multiply negative 2 times positive 2 gives you the minus 4. On the bottom, you have x minus 4 times the square root of x plus 2, which is this. You can see now that the x minus 4's will cancel each other, and that leaves us with 1 over the square root of x plus 2. That's the limit as x approaches 4. Direct substitution, replacing x with 4, you'll end up with 1 over square root of 4 plus 2. Square root of 4 is 2, and that's going to be 2 plus 2 on the bottom. So our final answer is going to be 1 over 4. Here's question 19. F of x is the square root of x. We're looking at the limit as h approaches 0 of this expression. First, let's find f of 2 plus h. Well, that's just going to be the radical, or the square root of 2 plus h. And then f of 2 is going to be the square root of 2. So that's what we have on the top. Next step is to multiply the top and bottom by the conjugate of the numerator. And the conjugate of the numerator is the radical plus radical on the top and bottom. All right, next step is to multiply the numerator together. Radical 2 plus h times radical 2 plus h is just 2 plus h here. Radical 2 plus h times radical 2 will cancel with the negative radical 2 times radical 2 plus h. So then you multiply the negative radical 2 times the positive radical 2, and that's just going to be negative 2 here. In the top, 2 minus 2 cancels out, leaving you with just the h. The h on the top and bottom now cancel each other, and so now we have 1 over square root of 2 plus h plus the square root of 2, and that's the limit as h approaches 0. Doing direct substitution, replace h with 0, and you're going to end up with 1 over square root of 2 plus square root of 2, which is also known as 2 square root of 2. So the final limit is 1 over 2 square root of 2. Here's number 20. F of x is 1 over x, and that's the limit as h approaches 0 of this expression. So first, what is f of 3 plus h? And then what is f of 3? So f of 3 plus h is going to be 1 over 3 plus h, and then f of 3 is just 1 over 3. And all of that is over h. And now, when you've got this complex fraction, we need to find the common denominator of these two fractions on the top. So we have 3 plus h, and we also have a 3. The common denominator is going to be 3 plus h times 3. So we'll multiply by 3 plus h times 3 on the top and bottom. 3 plus h times 3 multiplied by this first fraction, that's going to cause this 3 plus h to cancel with this 3 plus h. Then you'll have this 1 multiplied by 3 left over. 1 times 3 is this 3 here. Then if you multiply this common denominator times 1 over 3, the 3 on the bottom here cancels with this 3, and that leaves you with 1 times 3 plus h, which is just 3 plus h here. And then we bring down the minus that's in the middle. The 3 minus 3 cancels out, and then the h becomes negative. So that's negative h on the top. The negative h on the top cancels with the h on the bottom, and that leaves you with negative 1 over 3 plus h times 3. We can now do direct substitution by plugging in 0 for h, and that's going to leave us with negative 1 over 9 as our final limit. And our last question is number 21. f of x is 1 over x, and then we're looking for the limit as h approaches 0 of this expression. So what is f of x plus h? That's going to be 1 over x plus h, and f of x is simply 1 over x. We'll need to find the common denominator, and the common denominator is going to be x plus h times x. So we'll multiply by x plus h times x on the top and bottom. Now this x plus h times x multiplied by this first fraction, that will cause the x plus h's to cancel out, leaving us with 1 times x. And that's just x. And then x plus h times x multiplied by 1 over x will cause the x's to cancel, and that's going to leave us with 1 times x plus h, which is just x plus h, and the minus in the middle carries over. X minus x cancels out, and then the h becomes negative on the top. The h on the top cancels with the h on the bottom, leaving us with negative 1 over x plus h times x. And then doing direct substitution, let h become 0, and we end up with negative 1 over x squared as our final limit. All right, that concludes the quiz review for this unit on limits.